introduction to couple workflow. My name is Helle Folberg Rasmussen, and I'm head of performance and simulations at Microshape. With me today, I have my colleague Rasmus Nielsen, who will present our free Grasshopper script, and Christian Lygum, who will be moderating the Q&A session in the end. So if you have any questions, please use the chat function, and we will answer them in the end. In this webinar, you will get an introduction to the BBC workflow and why we recommend coupled simulations. We'll also get a tutorial introduction on how to use our free Grasshopper script for making your own coupled workflow, and we'll give you an introduction to our free tools and guidelines. Please note that the webinar will be recorded and will become available on our website afterwards. This webinar is the last in a series of 3 webinars on how to SimShade. So just a little bit about SimShade. SimShade is a free online calculation tool validated by Fraunhofer ISE in Germany. In order to get access to all features of SimShade, you need to create an account, which is free. And SimShade can be used for engineers, architects, contractors, facade builders, glass manufacturers, and building owners alike. In this webinar, we will go behind the scene of SimShade and look more into the building simulations that are provided in SimShade, because this is the BBC workflow. It will become quite nerdy, so please let us know if you have any questions. In SimShade, we used coupled daylight and energy calculations. By couple, we mean that we keep the geometry and assumptions in the model in only one place. This way, we ensure that all assumptions are aligned and that the shading schedule used for the indoor climate simulation is also used in the daylight calculation. And furthermore, we used climate-based calculations for both energy and indoor climate and for daylight. Coupling the calculations means that we always consider only one building and that the gap is limited between design and the actual performance. And in this way, we believe that we can create buildings with a higher likelihood of sustainability. This is not always the case in the building industry. Usually, engineers from multiple departments perform daylight and energy calculations on the same project. However, they use different calculation programs, different models, and often the assumptions are not aligned. This often means that the solar shading is only considered in the indoor climate simulations, but not in the daylight simulations. And 2 different buildings are designed. By coupling the daylight and energy calculations, you have all the essential information in only one place, without the risk of branching off your building design in multiple departments. In this way, you can work more dynamic in the process for optimizing your building design, and you are limiting the gap between design and actual performance, creating buildings with a higher likelihood of sustainability. The workflow that we use for SimShade is called BBC workflow. Our workflow works by taking our shared assumptions, thus the room geometry, the window description, and the weather data, which the workflow can help you find and feed those into Grasshopper. In Grasshopper, the simulation startup can now be finalized, including materials and simulation parameters. When the model is ready, you start your simulation, and Grasshopper will feed the given information to either Radiance or Energy Plus, but depending on the type of simulation you want to run. To translate your input into something these calculation engines can understand, the workflow uses 2 auxiliary plugins for Grasshopper, respectively Honeybee and Ladybug. The workflow works with both static solar shading, such as microshade, and dynamic shading, such as external lamellars or screens. However, it can easily be modified to suit exactly your needs. We have made a version of the BBC workflow available for free at our website for you to use as a template to create your own couple workflow. You can find the guideline on the section that is called for professionals, and then you need to go down to the download section and choose the guideline to coupled energy and daylight. And here you can download a zip file with the Grasshopper script and all the files that you need in order to run the script. So I will now let the word go over to Rasmus, and Rasmus will show you the Grasshopper script.
Thank you very much. And my name is Rasmus, and I'll show you the Grasshopper script. I'll just change the screen. Yeah, over to Rhino Grasshopper. Hopefully you all can see it now. Yeah. I'm going to take you through a tutorial introduction in our free Grasshopper script. I'll do that by showing an example where we get through all the different parts of the script. As you can see over here, we have the Grasshopper, and on the other side, we have the Rhino. The Rhino shows the geometry. And over the Grasshopper one, we can see where we have the shared assumptions. We have the radiation study. We have the data study, where we use the radiance engine. And lastly, we have the indoor climate study, where we use the Energy Plus engine. Let's start in the shared assumptions. As Hilde told you about, we have some shared assumptions. The first shared assumption is the weather file. In this case, I will simulate with a weather file for Copenhagen, but if you want to simulate with a file from a different location, you can use this component up here where I just turn true, and it will guide you directly onto a website where you can find a new weather file for another location. The next shared assumption is the geometry. That's over here. I'll turn this on. That's the building you see over here. The building is the geometry for the daylight part, where more simple geometry is used for the energy part. I can just turn off this geometry for the daylight part here. And you can see it's more simple here. The reason we're using a more simple for the energy part than the daylight part is because when we are calculating daylight simulations, we want to be pretty precise on the results. So we need some precise modeling of the window. You can also see there's a more precise frame here that there was in the energy part. The next thing in the shared assumption is the BSDF file, or the file we are going to simulate, the shading file here. Both for daylight and for energy, we have the MSF 1614. That's the shading device we are suggesting for our company. And the next one we have in as a comparison is the CLX. And we have some dynamic solution. That's the external screen and external blinds, where we have a base window as a low E and the screen and the blinds. The same goes for the energy part, where we also have our MSF 1614, the CLX. And down here we have just the base window because the dynamic part will be simulated in the energy part. You will see that later on. On these two sliders over here, you can choose which window you're going for. In this case, I'm going for a window of our own, the MSF. So I'll choose 0 on these two, and you can see the options coming out here. That is the MSF window we have chosen. Let's start on the simulation part. The first thing you need to do is making the radiation study. We are making the radiation study. I just zoom a bit out here so you can see the building a bit closer. We are making the radiation study because we want to make a shading schedule so we know when the shading should be active. To make a radiation study, the first thing you are doing is making 1 square meter on the facade, where we're making touch points on this square meter to simulate and find out how much radiation is going on this square meter. We're also using the weather file where we're using to create a sky matrix. And we need to make some parameters to make the simulation run. All it is collected in the analyze receipt. This is directly inputted in the run radiance. The run radiance is the component we use to run the simulation. Here you just need to put true on these two elements here to start writing it and running the simulation. And as any good chef, I've already created the simulation, so it's done for now, so we can always see the results. So we get the results out here in the outputs. We're using some information about the period here. And the next thing we are going to is our own component. Our own component is making a binary shading schedule. That's the shading schedule we're going to use in the rest of the simulation to get an idea on when the shading should be on and when it should be off when you're using dynamic shading. The threshold here is set to 200 watts per square meters. You can just double click in and you can make it another value, for example, 300 or 50 or something else that you want to in your case. Over here, you can see the shading schedule. It's just a series of ones and zeros, where 1 is when it's active and 0 is when it's not active. And on the top part here, we have a visualization of this. I'll just turn that on and zoom a bit out here in the corner. And hopefully it's a bit hard maybe to see because it's quite small. But here you can see the shading schedule, where the white part is when shading is active and the black part is when it's not active. It will be a bit way more clear on your own screen because you can zoom a bit more in and around them and look at it. So that was the radiation study. When we are done with the radiation study, we can continue on to daylight. First, I just wanted to zoom into the building so we can get a close look on the geometry we are working on. Yes. Yeah. Let's move down in the daylight part. The daylight part is here in the radiant segment. The first thing we're going to do is making all the materials for the geometry. We are pipelining all the geometry in here. You can see there's a surface here, and that's the floor, where we are adding on a reflectance of the floor. And we are going on doing this for the walls, the ceiling, and the frame, and so on. The next thing we are looking at is putting in the materials for the window or the shading system. Here we are adding in directly the file path for the BSDF file. And it's from that we are creating a honeybee window group we can use to start the simulation. The red part down here is if you're going for the dynamic solution, you need to add a window state segment. You can see right now the state is set to 0 or null, and that's because we're using a static and not a dynamic shading. But we will state some different states of the shading device. It was a dynamic shading. The last thing is the material is the ground. You can see the green ground outside here in the Rhino view. And that's the ground we are using as a material, where we're giving it reflections and making it to a red scene. Now we're done with all the materials. I can zoom a bit out. That's the first part here over in the left corner. Now we're going to make the analyze receive as dictates how the simulation is going to run. The first thing we are going to do is making all the grid points inside the room. You can see all the points lighting up now inside the geometry. The next thing we are going to take the weather file again and making it to a sky matrix. The last thing we are going to make all the options for the simulation. The first thing you need to look into is the complexity. We are going for a low complexity here, but you could also go for a high one. A high will take longer time to simulate, but will also get more precise results. The next thing is the receive type, and the receive time is set to 2, and that's because we're going for a 3-phase simulation. That's due to we have some shading device in the window. When we are done with the analyze receive, and we are ready to pipeline that into the run radiance. The run radiance is the same component we used in the radiation study, and you just put through to these 2 toggles. And when it's done and the simulation had ran, you'll get some outputs. The outputs is evaluated in 2 methods here. The first method is the SDA method, or the spatial daylight autonomy. Before we can get the results we are getting here, we need to create a daylight hour binary schedule. We are doing that by taking 50% of the hours in a year with the highest level of diffuse horizontal luminance. And from that, we are creating the daylight hours binary schedule. And that is in regulation with the EN 17037 standard. Now here you can see all the SDA values. That's over here. The next thing I'm going to talk about is the daylight autonomy. That's the component we use up here to calculate daylight autonomy. We have a threshold of 300 lux. And up here in the top part, you can see the average daylight autonomy. And the next thing is the heat map. The heat map is the visualization of the daylight autonomy each grid cells. Right now it can be quite hard to see, but I'm just gonna focus in. And then I'm going to move back and just turn off the building so it's a bit clear for you guys to see. So here we can see how the daylight autonomy is spaced out in each grid cell. I can see there's something more turned on. So here it's a bit clear to see. When we are done with the daylight analysis, and then I will continue on to the energy part. The energy part is the last segment down here. It's quite big, but again, it's starting off with creating all the materials for the building. Right now, I'm just going to turn on the building so we can see what we're working on. As you can see, it was a more simple geometry. Let's first talk about the materials. For the floor slab, we are now using, instead of reflections, we are using the EP construction material. The EP construction material is created down here in the bottom. An example here, you can see where we have all the layers in the material. So we're combining all these layers and creating a floor, a wall, an internal wall, and a ceiling, and so on. All this is given as some kind of thickness, and the thickness is added on in Energy Bus. When you're done creating all your materials, you can just pipeline them directly into EP construction, and we are ready to go. That's all the material for the geometry. Now we just need the window. The window is, again, we are just taking the EP construction from the BSDF files menu up here. I just go back so we are all sure what we're taking it from. So that's up here. So when you have chosen the energy and the file you want, energy BSDF file you want to run, up here in this slider, it will continue on directly into this add honeybee glazing. If you're going for a static shading, as we are going for right now with the MSF window shading system, you're going down in this segment here. That's the static shadings. Here you just need to make sure this is turned on, so the shading material is added to the library. If you're going for dynamic shading, there's one thing more you need to look into, and that's the red box here, where you're deciding if you want to go for external blinds or external screen. So you just put the slider to 0 or 1. And then the things down here will start running. The things down here is the creation of the external blinds or the external screen. I just ran them before so you can see how it will look if you was going for dynamic shading. So that's the shading device outside of the window. I'll just turn them on as we are going for static shading. Now all the material is created and we are ready to begin on setting up the simulation. The first thing we are setting is the zone thresholds. And first we are going for the cooling set point and the heating set point. And that's 22 and 24 and 22 degrees here. The next thing is the zone schedule. We are just using a normal working day schedule, 8 o'clock to 5 o'clock. As you can see down here, and the weekends off, so it's just a normal working schedule we are using here. And again, when there's a red one, you need to make sure that it's put through to making the schedule. The next thing is the zone loads, and that's things like the equipment load and the ventilation per area you need to decide on. The next thing is the Energy Plus output. This is here where you define what you want to get out of simulation. That's really important because you need to define the correct things to get the correct results out. And the last thing up here is just the simulation parameters. Now you're ready to run the simulation. You can see here I've already ran the simulation, both toggles set to true, and I get some errors. The errors just right now saying that there's some materials missing. But as I also mentioned earlier, there was some additional strings. You can see them down here, and I'll just go back to show you where I found them. The option here, additional strings. Reason additional strings because the BSDF file is really complex, so some additional string is added directly to the simulation. So it's saying it cannot find it in the library, but it's not in the library, it's some additional strings. So it's not a part of it. So it is working and working fully. If you was going for a dynamic solution, this string will also be added. That's the output variable. That's saying it wants to know how many hours of shading device is on time. I've already ran the simulation, so I get a result file. And for this component up here, I can see all the results. The first thing we're looking at is the cooling, the next thing is the heating, and the operative temperature. Down here in the last segment of the results, we can use this slider to see how many hours there's above a certain degree. So right now I put it to 20 degrees, and you can see there's 846 hours above this degree. This slider you can turn up to 26 and see there's 0 hours above this temperature. The last thing down here is the activated hours of the shading if you was going for dynamic shading. So this is not active because we are going for static, which always is on. Yeah, so that was my presentation of the software. If you have any questions, just ask them in the Q&A section. The last thing I want to say here is when you're downloading this software, you need to make sure that the folder is downloaded somewhere in your C drive or some iDrive or something like that. Because if you're going to download on a specific drive like a OneDrive, the paths will not directly work. So the paths that's created automatically here will not work, but only on the C drives. So thank you for listening. I will give the word back to Helle.
Thank you, Rasmus, for the presentation. I will just share my screen once more. If I can figure out where it is. So I believe you can see my screen again now. So yeah, again, thank you, Rasmus, for this tutorial introduction to the workflow. It is very comprehensive, so please ask questions if you have any. The last thing I want to tell you is that we have a lot of other technical material on our website. So if you go to what we call for professionals in the menu, and then further down to the download section, you will find calculation guidelines, not only for this BBC workflow, but you will also find it for other simulation programs like either ICE or ISVE, and lots of other different programs. You can also find some data sheets for the microshade solutions. You can find selection guidelines or what kind of glazing buildup you should use depending on the application of the microshade. We have some example of tender text that you can use, and we also have more in-depth knowledge about angle dependency of microshade and also for other glass and shading solutions. So go ahead and have a look at some of all these features, and then of course also we have the SimShade as I told you about in the beginning. So with this, I would like to turn to the Q&A session. So Christian, can you tell us, are there any questions?
There are a few questions. One of them you already answered. That was, where could I get the BDSF files for the workflow? And you just answered that on the homepage.
Yeah, you can. Yeah, the BSF files you can get. Yeah, some of the there will be some BSF files included in the zip file that you download for the Grasshopper script. But in case you want to do other solutions, those that are already in there, you can create new BSF files using Window, the program that is called Window from LBNL. They have a very easy to use program, so that you can create exactly the glazing and shading that you need to calculate.
Then I have another one here. Is it possible to calculate the daylight factor within the workflow?
Do you want to answer that, Rasmus?
Yes. Right now it's not possible to calculate the daylight factor. However, it is possible in Grasshopper to make something so you can calculate the daylight factor. We are not provided it, and we do not suggest that you use daylight factor, but instead you're using these climate-based matrices, as shading is not taken into consideration in daylight factor and these kind of calculations.
Yes, I think this is a part of the next question as well, because it's if I used a coupled dynamic workflow, I can't get enough light in the building with solutions, I think. Yeah.
Yes, and this is probably because if you are used to do daylight factor calculations where you do not take the shading into account, and of course once you apply it in the climate-based daylight calculation, the daylight availability will of course decrease. But this is a more realistic measure of how much daylight is actually available in the building, because in reality the shading will be used. It has been designed with that in order to keep the temperature low. So it is a more realistic picture of what you will actually get in the end. So therefore we do recommend that you include it, because this is the only way that you will design only one building.
Okay. And is it possible to combine two different solutions, for instance, a passive and a dynamic into the workflow?
You can combine solar control glass with, for example, external lamellars or something like that. That is definitely possible. It is in principle also possible to combine microshade with something else. So yes, it is possible.
And the last one here on this other comes in. How long time does it take to make a calculation in media?
Yeah, the calculation. The time is normally for like the energy part of the simulation, probably taking like 1 to 2 minutes. For the data part, it can vary a bit because in the first simulation you're going to calculate what we call the view matrix, and that was the view outside of the room. This matrix, to create that, it takes some time, so it will take probably like 10 minutes. But when you first have created this matrix, it will go pretty fast after. So it's probably like 2 to 4 minutes of the data simulation after you created this specific matrix.
Cool. And I will ask there's one more question here. Why is there both a DA and an SDA script in the workflow?
Yeah, we have created both the SDA and the DA because we want to show what's the different option of output evaluation. Yeah, so that's the reason why we have these two.
I mean, it's also possible if you go and download and have a closer look, it would also be possible to calculate the UDI that has also been included. So it is, of course, because we know that some prefer in the design phase to use one kind of daylight measures, and for legislation purpose, you might only want to use the spatial daylight autonomy, because but it depends on the country that you're in, what the regulation says, and what you want to use. So we have included several options, but we haven't included the daylight factor because we believe it's not good for comparison with solar shadings.
I do not have any more questions as I can see it here.
Okay. So then I will just summarize the webinar. We've now given you an introduction to the BBC workflow and showed how you can use our free Grasshopper script as a template to create your own cover workflow. We have shown you how to calculate the actual performance of shading systems with these coupled climate-based calculations. And we've also shown you where you can find these free tools and guidelines, and also the SimShade where you can find it. So we'll invite you to try out the Grasshopper script for yourself after the webinar, as well as try SimShade. And I would, if you have any questions or comments for some of these tools, you're welcome to write us. So you can write us with questions or comments on either SimShade at microshade.com or on support@microshade.com. If you want to know more about the BBC workflow, you can follow Microshade on LinkedIn. You can also watch in the guideline, we have included some video tutorials that are also find on our YouTube channel. So if you want to know more, you can see those. If you want to know more about SimShade, you can watch the earlier seminars, webinar 1 and 2. They can be found on our website. You can also sign up for our newsletters, and of course you can go and watch the whole How to SimShade video series on simshade.com. So thank you for your attention. Have a good day.